So far all the complex numbers we've been discussing have been written out like this in Cartesian form, sometimes referred to as rectangular form. Now we're going to talk about how we can represent these on an Argand diagram, which is like a Cartesian plane, but it has a real axis and an imaginary axis. So for instance, the complex number u, 3 plus 2i, 3 units across the real axis, 2 units vertically, locates this point here. Typically we draw a directed line from the origin to show where the point is in relation to the origin. The length of this line, the length of this arrow, is referred to as the modulus of u, represented by parallel lines. The angle, which is measured from the horizontal axis in an anti-clockwise direction, is called the argument of u. Now if I complete that little right angle triangle, you'll see a very familiar situation that you've seen all sorts of other situations. So to find the modulus of u, we apply the Pythagoras theorem. Remembering this is 3 units and this is 2. 3 squared plus 2 squared, 9 plus 4. So root 13 is the modulus, or the length, of this line. The argument, inverse tan, the opposite side here is 2, the adjacent is 3. So inverse tan 2 over 3. Being careful to work in radians, complex numbers arguments are measured in radians, and to 3 digits I'll call this decimal 588. Typically the argument of a complex number would be given between negative pi and pi. So either from the positive x-axis to here or to here. That's modulus and argument.